my normal day job as a civil engineer, I recently got a new project. I got to work on an elementary school, which is really cool because I actually design all of the fun things like plan out the play areas or some landscaping areas. The things that typically look kind of pretty when you show up. It kind of got me thinking, what did I enjoy as a kid when I was in elementary school? And really, I came up with two answers. Answer one was a big hill that we would always hang out on. It's kind of the spot. Answer two was pine cones. At my elementary school, pine cones were everywhere. Whether you were hitting them like you would hit a baseball, or stepping on them and falling over breaking your ankle, or even throwing them at your friends like they were a grenade, you could never avoid them. This also begged the question to me today, what is a pine cone? Did pine cones evolve from something? They must have. Are there old pine cones that are going to be way crazier, like dinosaur pine cones or something? What even is? What do pine cones do? What's their function? So I looked into it, and this is what I found. First, if you could hit the like and subscribe button, it's totally free for you, and it helps me out drastically. Leave a comment for the sake of engagement. About 300 million years ago, the Earth was in a period called the Late Permian. This period on Earth was notable because of its lush jungles that spanned the entire globe, incredible biodiversity, and even the first reptiles to ever walk the Earth. Which means, yes, pine cones predate the dinosaurs, and even predated the flowers and fruit. They did not, however, predate ginormous insects that nobody asked for and nobody wanted. I mean, who wanted a cat-sized dragonfly flying around, or a cat-sized scorpion to run away from? And when you get away from both of those, guess what? You have an 8-foot-long centipede. I think this is saying that it's the tallest insect ever, or the largest insect ever. I'm good on that. Nobody asked for that. With the abundance of plant life during this period, it's not at all shocking to hear that a lot of the plants that we see today have evolutionary history to this time period. But in our case, a particular type of plant called the gymnosperm or the gymnosperm evolved. These plants were separated from others by having otherwise naked seeds just kind of exposed to the air, right? They didn't have flowers, they didn't have fruit, and they didn't grow by propagating other root systems. Plants pretty quickly caught on to seeds because they're a really good way for plants to put other plants elsewhere. However, protecting the seed is a dual problem. On one hand, you wanted the seed to be vulnerable, so that way they could successfully grow out of themselves and into a plant. But on the other hand, you didn't want the seeds to be so vulnerable that they ended up rotting or being eaten, or otherwise destroyed by the environment they're in. Enter the pine cone, or as it's actually called, the conifer cone. But I will keep calling it a pine cone because that's what it's called. The fossil record is really clear. And what's most shocking is that these pine cones look almost identical from today to back as close as 60 million years or as far away as 360 million years ago. Which also means that many of the functions of the pine cone must be identical because today they have those functions, and so in the past they must have also had them. For example, many pine cones today will actually close when they are wet. It might seem counterintuitive, but you don't want to see seeds be wet in the wrong conditions. Otherwise, they'll just rot, and they'll never be able to actually grow into plants. Think of root rot if you water your indoor plants too much. By closing when moisture is present, they are allowing the pine cones to be carried by water or to find a spot off of the tree that is more conducive to seed growth. It dries out a little bit, and boom, the seeds find the right conditions to sprout. This exact function is found in fossil record pine cones dating back 200 to 300 million years old. It's actually pretty incredible that nature was able to get it so right so early. Another example of this is wildfires. Some of you may know, but here in California we have pine cones that will close up and only open if the pinecone is on fire. It literally waits for temperatures exceeding normal temperatures and entering wildfire territory. The same patterns are found in pine cones, also dating back to 200 and 300 million years. These pine cones even then would wait for the forest to burn down. Before dinosaurs even walked the earth, they were able to capitalize on the environment just as today. Think about all the different species of animals or plants that have all had their time and all went extinct. Somehow, through multiple mass extinction events, the pinecone persisted and is so similar now to the pine cones that we see today. The primary function of the pinecone is to protect the seed, really. But I didn't even know this, but there are actually male and female pine cones. If you've ever seen a pine cone that is extremely small, this is most likely a fully developed pine cone, but it's just the male version of it. And the pine cone that we probably typically think of size-wise is actually the female cone. They're much bigger. The differentiation is also in the fossil record, so even male and female pine cones isn't something particularly new. Again, speaking to the wonderful guess of nature to figure out pine cones so early. Another thing fascinating about pine cones, as ridiculous as that sentence is that they don't have any muscles, obviously, but they are actually capable of moving around, which doesn't make sense because we typically associate that with animals. Well, so what do I mean? Moisture and temperature play a phenomenal role in the pine cone's evolution. You can see that pine cones typically do well in arid, relatively dry, and cold places. Nutrient-poor places where flowers wouldn't typically be. Because of this, they're able to use these changes in temperature and changes in humidity to actually move around and flex with the environment as it changes. The mechanics of the pine cone will do certain things under certain conditions, which is so cool from the plant's perspective because now they can adapt and change depending on the environment, setting up their seeds for the best possible chance. Pine cones today do have different sizes and shapes. In fact, the biggest pine cone ever is called a Coulter pine. It produces cones up to 14 inches long and over 10 pounds. They actually have developed a nickname for being so heavy. It's called the Widowmaker. As you could imagine, walking under one of these trees with 10-pound dumbbells waiting to fall off and hit people is actually really, really dangerous. There are certainly things in this world more interesting than the pine cone, let's be honest. But it's kind of neat to think that all these pine cones I've seen in elementary school, or the ones that I may end up seeing tomorrow, date back to such prehistoric evolutionary history, and are also so simultaneously complex. So the next time you see one of these, pick it up, look at it, marvel at it, because there's not a whole lot around you that is old as it. And if you can, leave a like, subscribe, and leave a comment for the sake of engagement. It would be unbelievably helpful to me. It's free to you, and it means a world of difference. See you in the next video.